Welcome to the second part of your guided notes. Now we are going to convert these next three fractions also into decimals. So we have 1/3. So we have 1/3. So that means we have 1 divided by 3. So 1 is going to be our dividend, 3 is going to be our divisor. So we know that 3 cannot go into 1. So we're going to place a 0, and then we need to place our decimal point. So if it can't go into 1, we can add a 0, and we know 3 can go into 10, a total of 3 times. And 3 times 3 is 9. So if I subtract 10 and 9, I get a 1. Then I am going to bring another 0 down because 3 can't go into 1, and I have another 10. Like before, we said 3 can go into 10 3 times. Well, 3 times 3 is 9. So we're going to subtract. 10 minus 9 is 1. 3 can't go into 1 again, so we're going to bring down a 0. We have 10 now for a third time. 3 can go into 10 3 times. And 3 times 3 is 9. 10 minus 9 is 1. Bring down a 0. And then we have 10 again. So as you notice, this is going to be a pattern where 3 is going to keep repeating. So now that we know 3 is going to keep repeating, we can stop and say 1/3 is equivalent to 0.3, and then we need that repeating bar above the 3. Okay, so now let's look at the next one. We have 2/3. So 2, the numerator, is being divided by 3, the denominator. 3 can't go into 2. So now we're going to place our decimal after the 2, and we're going to change it to a 20. So now we have to think 3 can go into 20 how many times? Well, it can go into 6 times because 3 times 6 is 18. Okay, now subtract. We have to do 20 minus 18, which gives me remainder of 2. I'm going to bring down a 0, and I have 20 again. So 3 can go into 26 times because 6 times 3 is 18. 20 minus 18 is 2. Bring down the 0. We're back to 20 again. So as you can see, this is another pattern where it's just going to keep going and is never going to end. So therefore, we can stop there because we see the pattern that is going on. And I'm going to write 0.6 repeating. Okay, for this last one, I'm going to need a little more room. So I'm going to just erase this really quick. And my next problem is 7/11. So 7/11. So I have 7 is being divided by 11. 11 cannot go into 7, so I'm going to put a 0. I need my decimal point after the 7. We're going to bring that up. So now I'm going to add a 0. I need to think how many times 11 can go into 7. And it can go in a total of 6 times. And 11 times 6 is 66. So now I'm going to have to subtract. I need to subtract 70 minus 66, and I get a 4. Bring down a 0. Now I have 40. So 11 can go into 40 3 times, and 11 times 3 is 33. 40 minus 33 is 7. I'm going to bring down a 0, and I get 70. So we had 70 before, and we said it can go in 6 times. 11 times 6 is 66. 70 minus 66 is 4. Bring down a 0, and I have 40. 11 can go to 40. We had this before too, 3 times. And that would be 33. Subtract, we get another 7, which is going to be 70. So you should start seeing a pattern. So here I have the 6-3 that is repeating. So this is equivalent to 0.63 repeating. So we have a name for these types of decimals. And the name for these types of decimals are repeating decimals. And that would be decimals that keep going on and on forever and they never end. So like in the first one, the 3 will keep repeating forever and ever, will never end. The second one, we had the 6 repeating, and the last one, we had the 63 repeating. So if you can please write the word repeating on the line for the second section of the notes. When you are finished writing that down, you can flip your notes to the back side, and then you are going to do all of the practice problems on the back.